Welcome to devMode FM, a podcast dedicated to the tools, techniques, and technologies used in modern web development. I'm Patrick Harrington from Mildly Geeky in Boston.
I'm Andrew Welch from NY Studio 107.
I'm Earl Johnston from Hypatia Industries.
I'm Jonathan Melville from MDD in Atlanta.
Today we're going to be talking about Git as a version control system, and we have on Ryan Irelan from Mijingo.com. Ryan, great to have you.
Hey, thanks for having me.
Great. For anyone who doesn't know Ryan, tell us a little bit about yourself. Some may know you from Expression Engine days and Mijingo.com, but love to hear more about your journey, how you got into training and recording webcasts and training materials.
Sure. It kind of goes back to being actually in graduate school. I went to grad school for something very unrelated to technology. I went for German and German literature.
It's a common crossover.
That makes complete sense. Yeah.
So, but one of the things you do when you're a grad student in the humanities is, because there's really no money there. So
yeah, you realize you're not going to have a job when you get out of college.
Besides that,
yeah,
there's like 4 German jobs in the U.S. or something. But one of the things you have to do is you have to teach, and that's part of like how you earn money, so you can pay for rent and stuff. So I did a lot of teaching. I taught undergraduates German, and one of the things that we were required to go through was a class in my first semester on how to teach. And so it was more of like sort of learned about like pedagogical approaches to teaching a foreign language. And so fast forward.
Wait, pedagogical.
Oh, thank you, because I was like, I don't know what that means.
No, hold on. This is a G-rated podcast. You can't be saying stuff like that, right?
So I basically learned a bunch of tools and techniques for teaching foreign language, and then fast forward like 5 years later, I was working for a small web agency, and I had started using Expression Engine, and I decided that this is kind of like, I feel like I can teach. I've done enough projects. I feel like I can teach this, and this is just kind of like learning a language. Like when we taught German, we taught it in context, meaning it wasn't like rote memorization of verb conjugations, or in German all the nouns have gender, so there wasn't like rote memorization of that either. You just did everything in context. You had like very real world scenarios.
Slackbot will not like the fact that all the nouns have gender.
Yeah, exactly.
That is no good.
And then
That's a deep cut.
What I realized was going even further back to the late 90s, I actually lived in Germany and took a class to actually learn German. It's where I originally learned it. And they actually did the same thing. They taught me German the same way that I ended up teaching undergrads German, but I didn't actually make those connections for a while, because sometimes it takes a while for those things to make sense to you. And then it all sort of like was just like this big circle, and I realized that, this is probably a really effective way. It's proven on me. This is a person who, like, I was like a C and D student in foreign languages in like middle school and high school, so I wasn't particularly gifted at that. But it was the technique, and I realized I could apply that to technology. It's the same thing learning, a CMS or Git in what we're going to talk about today, or a programming language. It's the same thing as learning a foreign language, in that there's a set of rules, there's syntax, there's like all that stuff that you have to learn. You just have to, but you do it with projects. So instead of saying, this is how you, echo something in PHP or whatever, or this is how you build a web app, you actually build something with the people that want to learn. And that's sort of been the underlying approach that I have for teaching stuff. You'll see, like, any of my courses that I do, they're typically done with some sort of sample project.
Hold on to. I'm sure there are a lot of listeners. I'm one of them who learned a lot about Expression Engine, later Craft CMS through your courses, and they've been a great resource. One of the other things, and the reason we have you today, is Git, which is a very popular version control system. I don't have the numbers in front of me, but I feel like at this point it's overtaken Subversion and Mercurial and all those. How did you decide to get really deep into Git, and why?
I started using, my first version control system was CVS.
Okay,
and
that takes me back.
which if you've used, like, it's sort of like progressively getting better, right? Because when we switched to Subversion, we're like, oh, this is beautiful, so much better. And then we switched to Git, and we're like, wow, this is actually really good. So I'm excited about what's coming next. I don't think there's going to be anything, but I got into it. I mean, I just used it, right, as like part of my work. And then I realized that there's a lot more there than what you just do day to day, Git add, Git commit, Git push, Git merge, things like that. That there's a whole lot there. And I started researching kind of where Git came from, and like that it was created, sort of came out of the Linux kernel project from the Linux kernel team.
Thank you, Linus.
Yeah, exactly. And their reasoning for creating it was that they were using a tool called BitKeeper, and they had and it's like an
God, I
enterprise,
remember that. That's scary.
Yeah. And so they were using that, and they were using it for free because they were an open source project and they had this license. And then I believe, I'm not sure if ownership of BitKeeper changed hands, but there was some change, and they were no longer allowed to use it. And so what they decided was, we're a bunch of smart people and we're distributed across the world. We need something that's going to be a distributed version control system. We do not want to rely on a single point of failure, whether that's a centralized database or like a company that owns this. We want everyone to have a full copy of the repository on their machines, and where you can work offline. Like, we want to just really create something that fits our team. And that's what they did, and that's sort of how it was born.
So I do have some numbers here. I did, our crack research team has come up with it. So these are from 2016, so it's actually probably even more skewed towards Git these days. But Road Code tweeted out a survey. It came back 87% Git, 6% SVN Subversion, 5% Mercurial, and 2% Perforce. Now, I don't know what the demographics of the people are who follow these guys, but in terms of the web search interest, it looks like Git is 70%, SVN 13, Mercurial 13, Perforce 1.5. So we're talking about basically Git has the same kind of dominance in version control that Google has for search.
Yeah, maybe even more so. Yeah, so I think it's interesting. One of the reasons we have you on is to get deeper into Git. I feel like I'm one of those users that does a push, a pull, a fetch. Sometimes we'll cherry pick or merge. I like Rebase because it doesn't give me that tangled up branching list when I'm working with other people. But I still feel like I've only gone skin deep on what Git is. So for my first question, Ryan, why is Git different than Subversion? Why is it better than it? Do you know from a internals perspective and how it handles version tracking? Why is Git, as you said, you feel like it may be almost like the best last version control system out there? I don't want to put words in your mouth, but
I also was quoted in the Wall Street Journal one time saying that was dismissing Twitter as a fad for young people.
Sick brag.
So
Sick brag.
Probably shouldn't listen to me about any of that stuff. Let's see. So I think a good way of start to think about Git is just to think about it in terms of commits. So sort of push away. Everything else is like a tool or a way of connecting commits. So like a branch is really just pointing to a commit as a starting point. So if you kind of think about Git as being a revolving sort of around commits and pointers to commits, then it really starts to make sense. So if you have your master branch and then you do Git branch develop, so you create a branch called develop, then all that branch is there's a text file that has the hash, sort of that long string of characters. It has that in a file with the name of that branch. And that's how Git knows the beginning of that branch.
And what does that point to?
I'm sorry?
And so that's how it knows where it points. But what is it pointing to? Like, what is in that file?
Do you mean it's the branch, like the refs file for the branch?
Yeah.
It's just the hash. It's just a text file.
So it's literally just a text representation of here's the hash of the commit where I'm currently pointed at.
Right, and that commit obviously references a commit that's in the Git storage database.
Yeah, that's what I was trying to lead to, is that it is pointing to a commit.
Yeah.
Yeah.
Got it. And I mean, how is that different from Subversion or anything else, and why is it better?
I can't speak to the the internals of Subversion so much, just 'cause that's not really my expertise. But I do know that that what makes Git really unique is that it is very lean. So if you look, if you've ever used Subversion and you created a branch, you know that it sort of like copies everything again into a new branch. Or if you create a tag, it copies everything again. Where Git is just creating a reference to a commit, and then that's it.
Yeah, it's kind of like commit soup, right? I mean, you've just got all these commits, and all the branches and tags and all those kind of things are just things that point to specific commits, right?
Right, exactly. Yeah, so if you think about tags, they're really nothing except just a pointer to a commit, just like a branch is, just like, trying to think like what another example would be. But the main thing is to remember is that if you just don't get lost in, if somebody's sort of trying to like understand it, like don't get lost in all of the things, all the tools that you can use in Git, like you can branch and merge, and just understand that, like, I wouldn't say like that the commit is like the smallest unit in Git, but you can think of it that way, and think that that's sort of like where everything operates, is at the commit level. There's other, like, under the hood, there's other things happening with, like, trees and blobs and hashing objects and all that stuff. But from the top level, as a user interface level, we're just working with commits.
So I have a question for you about how all of this stuff works. So let's say I take your scenario and I create a branch called develop, right? And then I push a bunch of commits against develop, which is going to change where the develop is pointing to. And then I switch back to master, and let's say I'm doing horrible stuff and I'm pushing commits against master. How does it know which commits are associated with which branch? Like, because now we've got some commits that are pushed against the develop branch, and we have some that are pushed against the master branch. If it's all just commit soup, how does it know which commits belong to what branch? How does that work?
Well, it's storing those in, like, it's definitely not like just commits that are just kind of, I mean, they're definitely like floating out there, but there's also like a storage engine to it. So it's storing those. And it's also, Git is also, like that commit is like when you check out like a new branch, like, or an existing branch, and it, there's something called head, which is like the current state of that branch, and head always points to a commit, right? Now that commit is captures not only like the changes you made to the files that are part of that commit, but it's actually the entire tree, like working tree of the project. So if you think about it, I'm introducing like new like Git terms here as we go, but if you think about it, like if you had like a web app and you had like, and you initialized a Git repository in the root of that app, that whole thing is considered when you create a commit. It basically hashes that entire tree. So a tree would be like a series of directories, basically, and then inside of a tree would be like files, which in Git terminology are called blobs. I'm lost. Okay.
This is why I always stay away from the .git folder. I know I'll break something.
So, but I mean, I know you joke about it, but actually, I think that's actually one really good way to learn, is to actually go into the .git folder.
Sure.
So for anyone that hasn't done it before, if you go into your project and then do like, I always do ls-al, so you can look at hidden files, and then you'll see like .git, and you can just cd into .git. And then you look inside there, you can ls and just kind of like poke around, and you'll find something called refs. You go in there and you can see like all the different reference files that actually point to commits. And it'll help.
Now we're getting into how the sausage is made. We're scaring people.
Yeah. And so, not to like, toot my own like courses here, but they actually have a course called Git Under the Hood, which kind of does this whole thing. And I kind of like step through all the stuff. And then I, my big, like when I teach in person at, places, the big, like, sort of one of the big like tricks I do, not really a trick, but is to do the, what I've like jokingly called the world's longest commit. And I actually create a commit using all of the like long form commands. So here's an interesting tidbit for you. When you do git commit or git add, that's actually a high level command that runs a bunch of lower level commands. So when they were first, the Linux kernel team was first creating Git, they actually created all these like, low level commands that actually, did the work. And that's what they used. And then as it developed and matured, they added these higher level commands.
I can see the kernel team making the commands, and then mortals actually got involved, and they're like, "What the what the hell?"
Right? Yeah, exactly. And they affectionately refer to the different commands as those underlying commands are called the plumbing. So the commands that make things work, and the higher level commands that we all use every day are called the porcelain. Right? It's what you interface with. You don't stick your hand in the tank and pull the plunger. Right?
That's what you pee into, though.
Right? You're not like you have something nice that goes over the hole that actually goes out down the pipe. Right?
Gotcha.
So that's nice and comfortable. And that's sort of, but I mean, you can look it up, porcelain and plumbing, like Git porcelain and plumbing. It's terminology that they use. It's not something that I made up. It's not like a
that's cool.
Terrible bathroom joke.
But you still have access to these low level commands. So like if you wanted to, you could still run them directly.
Oh yeah. Yeah, absolutely. You can hash objects. You can.
If you're a sadist, you can do that.
That's what I was just thinking. Like, if you really hate yourself, get in there. Yeah.
You can go ahead. Like when I do this step through demo of like the world's longest commit, I do it in this course that I was talking about, Git Under the Hood. I actually do that, and I'm like hashing objects, with those commands, and then in order to update the work, like the when you run git status and you update, and it says like there's, these changed files or these modified files, these are, staged for commit. In order to update that, you actually have to go in and edit the reference file for head for that branch and actually put in the new commit. And I do that all sort of by hand, just to kind of see what happens behind the scenes.
So this isn't even, do you use tower or source tree or command line? You're actually hand authoring in Sublime or whatever your own commit files.
Yeah, or in Vim or whatever. Yeah, exactly. Yeah.
Dear God. Hey, Jonathan, if you're going to try this, Jonathan, I see a Git revert in your future.
It's totally impractical to do.
Right.
But it's for demonstration. It's just to show like how
fundamentals.
How this. Yeah, I would say it's even like not even like it's below fundamentals. It's like I want to really wrap my head around.
I don't even think Linus uses Git that way.
No, nobody does. I mean, why would you? It doesn't even make any sense.
So you're going to be like, here's what you can do, but please don't do this.
Right. That's kind of what I say, right? Don't do this, but this is like how it all works. And that's only like that's not how I teach Git, but it's just a way of demonstrating like one part of it.
That's how you establish dominance.
Well, right? It's probably a good like exercise in humility, right? To realize that there's a room full of people that like hardly understand because you're talking about an abstraction layer of Git, right? Like, so there's people that are admittedly like, I don't quite understand surface level Git, and you're like, oh, well, there's a whole nother level that you don't even, you know what I mean? It's just like humbling to remember.
No, that's Ryan.
How little you know.
That's Ryan establishing dominance right there.
Yeah.
Everybody's crying at the end of the session.
Yeah.
No, most people are just like, some people's eyes glaze over, but
that's what I was thinking. It's like a room full of people that are just like, I'm gone. I'm checked out.
Yeah. A lot of time in the past, I've taught people that do software development that is, I'll say like, just like out of this world. So they love sort of like this kind of nerdy detail. And that's one of the reasons that I actually added it to my class. But it also, this leads, like doing that leads from like the pieces of Git, like the fundamentals, things like there's a repository, there's something called an index, right? Like the index is when you run, Git status, right? And then you do Git add, you're kind of staging things. You can think of it as this middle area between save to the repository on the right and your project files and directories on the left, what we call the working tree, which is anything that's part of an initialized Git directory. And then I talk about like a commit. I'm talking about all these little pieces and actually show them how these pieces work inside of Git. And that's sort of like the culmination of that part of the lesson. I don't just show them and be like, this is how we hash objects in Git. I mean, that would be kind of silly.
Yeah.
I think it's cool that you do that because it's really interesting when you think about a technology that a lot of us use every single day, and yet we can use it without really understanding exactly how it works. So it's kind of interesting to sort of look behind the scenes and examine it at a low level, something that we just kind of take for granted. When we run a command, like, oh, well, what's actually happening under the hood? It's kind of neat to see.
Yeah, well, that's how we operate, right? I mean, there are tons of people that get in their car every day, turn the key, and they have no clue how that engine works. But
that's exactly right.
Yeah, but Ryan, I think that's really smart because I come from that school where I really like to understand how stuff works under the hood. But from a conceptual point of view, I think it's really important to kind of understand the paradigm that this thing uses, because then when you're doing like a merge or when all hell breaks loose and you've got merge conflicts, like you conceptually understand what's going on and you don't feel helpless, Yeah,
it's not as scary when this is just some commits and, there's been some changes, like the working tree is changed in a way that Git can't reconcile. So I need to go help it. One of the really bad examples I gave for Git was that, like a summer school, or not summer school. Gosh, I'm probably talking about my childhood. A summer camp counselor who is one of many counselors, and there might be 200 kids, but they're only responsible for a certain number of them, and they don't know who they're responsible for until they get instructions. And that's sort of like, Git is only responsible for the things that you tell it to be responsible for. And then you have to kind of you sort of, I work from there. I have a video somewhere on Mijingo.com where I talk about that, but I don't want to rehash. It's not a super great example, but the whole idea is just to kind of break it down into general terms of how kind of Git works from I think it's called the big picture of Git, I believe, or something like that.
Yeah. How does Git maintain order in terms of start to finish of, there are all these commits and you have a branch, whether it's master or develop or, upcoming release that is pointed at a certain place. How does each one know of what comes before or what comes after? How does that maintained?
Well, when Git stores in the database, it's always pointing backwards. So this commit is pointing to the previous commit to the previous. And that's talking about Rebase, right? Rebase is basically rebuilding that relationship, that sequence. That's why it's so dangerous if you do it on a project. For those that don't know, Git Rebase is one way of bringing in changes into a repository. It basically replays them. So it's kind of recreating that history. And it's called a rebase because base is the beginning of that repository. And you're basically creating a new base, the new beginning, and then you're replaying those commits and they're building up from there.
So when would I use Rebase? When would I use Rebase and when would I use merge? What would be the use cases?
Well, I'll turn it around a little bit and I'll say that you don't use Rebase. Because this is really important. Don't use Rebase on a project where other people are working on that project and relying on that history to not change, because Rebase does change. It's it's completely removing a commit from the history, right? You don't do that on shared projects.
What about if you're doing a pull, like a Git pull Rebase? That should be so pull is one of those weird commands because
a pull is actually like a fetch and a merge. So I believe it actually does a fetch and a rebase. Then I believe what it does, but I don't personally actually rebase myself on my projects because I think it's kind of dangerous. I know a lot of people do it because they like that it's clean. Like a lot of times you can get around conflicts that way because it'll do it away. But I kind of preach conflicts as being just a natural occurrence in Git. Like they're nothing to like try to like avoid or be afraid of. It's just
I think lots of people are afraid of it, and I think that people that use Rebase, that's exactly why they do it a lot of the time.
Yeah, and I feel like that's exactly it. It let me get past having to go and look at, okay, what changed in this one, what changed in that one, and just hoping that Rebase found a happy path through everything. But it sounds like it maybe it's okay most of the time, but it could be destructive some of the time.
Yeah, so if you were working on like like if it's a sort of a very contained project, maybe it's just like you and your team or something like that. But if let's say you had a project that was, like an open source project and a lot of people were forking it and stuff, and you start rebasing and pushing that up, like you'd have a lot of upset people as their entire history of their project, of their branch or their fork as they merge in has changed.
So it's taking a fresh look, as you said, that commits are almost pointers pointing back to the previous commit as well as what file changes were made. So it's really taking a fresh look and kind of stampeding over that old history.
It's replaying it basically, yeah, and recreating it, and and kind of cleaning it up. But my take is that I don't really see it being necessary in day-to-day work. But there are people that do all sorts of different projects from a much larger scale than maybe I've worked on that they may see benefits to it. So I don't want to sort of give a blanket statement, but I definitely shy away from using Rebase. I consider it like destructive in a way. The same thing as like Git, like a hard reset in Git, things that are actually just like destroying like changes. That's the kind of stuff you have to be careful about. I treat Rebase the same way. Even though it's not destroying commits, but it is rewriting, it's rebasing. It's starting with a new base and rewriting those commits.
It's like winning a war. You get to rewrite the history, right?
That's right.
So I've never rebased anything before. So what's the end after you run rebase? What are you left with? It's not like, because rebase, if I hear that term, if I'd heard it for the first time, it would make me think that if you're thinking it on the commit level, right, it would make me think it's condensing everything into a new sort of like alpha commit, right? Like here's the first level commit. We've just condensed everything into this, but that's not what's happening, right? Because you're saying it's not totally destructive of all the commit history. So is it just sort of trimming the commit fat a little bit? I'm totally not clear on what exactly happens during a rebase.
Patrick, why don't you chime in on what you see the difference is when you rebase versus when you were merging? Like, because that way it's like more of a practical.
So I'm a visual person, as Andrew knows. I like using Git Tower, and if I'm working on something and a teammate is working on something else, we'll have two branches, or as we're working on parallel things, it'll show a visual difference that, hey, at some point you guys started working on different things and you branched off. When I'm trying to pull their code in and reintegrate into my local Git repository, my local Git folder, if I don't do Rebase, I get a merge commit, and I think those are ugly and gross.
Okay.
Oh my God.
Okay.
But if I hit the Rebase button, it puts everything into a straight line for me.
Oh, I see. Okay.
So
So
it replays those commits. It goes back to the beginning of the history, and then it replays those commits one by one and tidies them up. It's literally going to the base commit and just redoing everything.
Okay.
I would, not to put you on the spot, Patrick, but I would argue
Stop
that merge commits are a really important part of a project.
Yeah.
Especially if you're working in like a Git flow sort of setup.
Mm-hmm.
Tower I think has built-in Git flow support.
That's why I love it.
Makes it easy to write the branch names. And so by default, like Git does, when you do a Git merge, it does what's called a fast forward merge if it can. And basically what that means is that if there's been no changes to the source branch since you branched off and trying to merge back again, it'll just like fast forward to your latest commit and just kind of like take what would have been a little bump and flatten it out. Because there's nothing there, right? There's nothing to reconcile.
Right.
There's been no changes. Now,
no FF flag, right?
Right, exactly. No FF or no. Yeah, exactly. So the thing with merge commits is that if you're doing something like git flow, they signify an important part of the project, which is merging into develop like a feature branch or something like that. Like these are major not major milestones, but major points in the project that you want to signify and you want to mark like what's happened, and that's what those merge commits do. A lot of people don't like them because they kind of dirty up the log output when you do a git log for a branch, but you can get rid of that. You can do git log with no merge commits present. There's an option for that as well.
Oh, interesting.
If you do git log, I'm trying to think of what would it be like. Is it git log -- help? Whatever it is, I forget or if you just do like man git and then look at the git manual, you'll see that you can slice and dice git log so many different ways to avoid that. And I'm not sure what the support is in some of the GUI tools for Git, but there might be that. So there's nothing wrong with like allowing fast forward merges if you can. By default, Git is set up to do a fast forward merge if it can. You can change that in the Git config, so it will never do those unless you specify it. Like you can just flip it the other way.
Got it.
But I like to see that full history of what's going on.
Yeah, my only comment on this whole thing, Patrick, is I know you like it to look nice and neat and trim and lean and all that stuff, but you really are basically rewriting history when you're doing a rebase. Like you are eliminating a lot of meta information that can actually be really, really relevant.
So, and if you don't have the merge commit, I mean, isn't it a little more difficult to rewind if you have to go back? Or, I mean, so like if you just accept a fast forward merge, it's going to be more difficult down the road to revert to your previous state.
Yeah.
It shouldn't be though, because you're not the fast forward merge will only happen if it can do it non-destructively.
Cleanly,
if like nothing has come in the interim, like if there's been no commits in the interim since you branched off. And so for like real low volume projects or low volume branches, like source branches, you can still revert back to the previous commit. It's more like, I think it's important to signify that merge, especially if it's like merging a feature branch into like develop.
Right.
Or, if you look at the Git flow diagram, then you can kind of see like why those.
You can go back and you can see what happened. And if you just are, or if you're doing merges, it's completely non-destructive from the point of view of changing any other branches at all. And if you're doing a rebase, it can be destructive, so that in the scenario you mentioned before, Ryan, where if you have a number of developers that are working on stuff, if you do a merge, you're not messing with any of these other branches. And if you rebase, then you're essentially, they're out of sync now with everything else that you're doing, because you've rewritten history, essentially. And there are times that, and it's usually when something, when the what hits the fan and you got to go back and fix it, that it's really useful to see the exact state of everything that happened and be able to go back and look at it and not just see a flat line, All
right, so put aside my OCD and stop hating on the merge.
Well, if it's just you.
Well, it's not just me.
It doesn't matter.
Well,
yeah, if it's just you, I mean, you can do whatever the hell you want, but
sure.
If it's a bunch of other, and I would say that the more complicated the project gets, the less you're going to want to be rebasing stuff.
Yeah.
But there still are definitely cases for doing it, for sure.
Yeah, so we've talked a lot about merging and branching. If, let's say, you're working on something locally, you make a change to a file, someone else from your team or from maybe an open source contribution, they've been working on a file, you try to pull down from that remote repository into your local, and it says, no, you can't do that. You have a merge conflict. How does Git decide what is a merge conflict, Ryan? Does it go line by line and say, well, if you are both touching the same piece of code but in different places, you're okay? Or does it do it on an entire file base and say, hey, you've both been working on the same file, take a look at this because you may have stepped on each other's toes?
No, it's line by line. If it can't, sort of splice those changed files together because there's, a conflict at a line, then that's when it alerts it. So you'll see those, different tools do it differently, but actually in the file itself, you see the right and left angle brackets, and it'll specify like where the branch you're merging in and where head is and what those changes are, and you have to go in and there's all different ways of resolving these merges. You can do it manually. You can just go in and edit the file and just pick the right thing. GitHub has a really cool tool where you can actually do it right in the browser now. If you get a merge conflict when you're merging a pull request in, I've used that quite a bit. It's just so much easier than having to like pull everything down and redo it again and push it up again if it's just like one or two conflicts.
Yeah, that's a really good point that I want to make sure people don't gloss over, is that the file that you'll end up with when there's a merge conflict will have all of that stuff in there. Yeah. Right. So you can actually go in and you can just like remove the stuff that shouldn't be there and it will all just work. But yeah, I mean, to get back to what Patrick was asking before, if it did do it on a per file basis, then, I mean, Git would be pretty unusable. It would be horrible for teams. Oh my God, Patrick added a space after this. Merge conflict, like we're screwed.
Right. Yeah, it would be the antithesis of a distributed version control system, right? It would just,
So that's what a merge conflict is then. It's when two people have changed the same chunks of code in different ways, and it wants to know, hey, which one should actually be used, right?
Right.
Should one take precedent, or do you need a new approach and merge the two of them a little bit?
God. I mean, I've worked with developers that if they see a merge conflict, they flip the table and they go take Xanax, and they're like, "Oh my God,
turn off the lights, go home." Nope.
Like this is the end of the world, So why is this not the end of the world, Ryan?
Well, it's not the end of the world because Git is protecting you from overwriting changes. So instead of flipping a table or, punching a laptop or just sort of like rage storming out the office door to go for a walk. Not that I've ever done that, but never. It's just to say, instead of doing that, just take a moment and just sort of, put your hands together like you just got done doing yoga and just say, thank you, Git. Thank you for protecting me from myself or from my coworkers or whatever.
Two people change the same thing. Tell me what you want.
Yeah, let's see what's going on here. Let's look at it and fix it. Now, I will say, so, one, don't be afraid of merges. They're not a signal that somebody failed or somebody made a mistake. You didn't like break the build. You might have, but like it's not like it's not a big deal.
Get blame.
Yeah, exactly.
Right.
But now but I think what I've found is that a lot of merge conflicts can be resolved via a more organized Git workflow. So like if you look at Git flow, Git flow isn't there to keep you from having merge conflicts, but Git flow is there to keep everything organized. And if you're doing that, then you probably won't have merge conflicts. And it also means, do you have like good project management? Are you assigning tasks properly? Are you assigning tasks, bug fix to 3 people where 3 people are touching the same file? Like, so you get down to like these like organization and workflow issues that will actually help you prevent an overabundance of Git conflicts. I think that's where it gets really exhausting for people, is because they may have a really chaotic workflow or process, and then on top of that, they get all these conflicts. And I would probably be rage storming out of my office too.
And I think you're absolutely correct that part of it is just setting up a workflow. Like if you have a team, even if the team is 2 people, designating who's going to be doing what. And then another thing is making sure that you are doing commits with a reasonable frequency, right? Because if you decide
commits is what I call it.
Yeah. If you decide to work on something for like 5 days and you've got a partner that's working on stuff too, like the longer you go between commits, the longer or the more likely it is that there's going to be some kind of a problem. And then, I mean, I've also seen it where someone goes off and they work for 5 days, and then they'll do a commit that will include like 20 different files, and it would say like work done,
Lots of stuff.
work done, push.
All right.
You know? And so what is an atomic commit, and how is that going to help us?
So the idea behind like thinking about like atomic commits is that you commit as frequently as possible. Not every time you type a new character on a piece of code, but if you solve like something or implement something new, even in pieces, like, so let's say I go in and let me think of an example off the top of my head. Let's say I'm building a plugin for Craft CMS, and I generate, I use your tool, Andrew, and I generate like the scaffolding for it, and I just set up the basic stuff in it. So generating the scaffolding, I would then commit that as initial commit.
Yep.
Then I would basically go through and just customize that, and I would then commit that as like, customized scaffolding. And then I would go in and piece by piece, let's say the first thing I wanted to do was to build out the settings. Then I would do like my first pass of the settings, and then, commit that as like, first pass at settings. Now that assumes that I can do a lot of this work in like a single sitting. But what you should also do is what I always tell people when I was like managing, web developers was that, don't leave your desk without committing.
Mm-hmm.
So even if you're not done, you can have committing and pushing in our case, but you can have like, first of all, you can, get distracted and have to do something else. Your hard drive could die. Somebody could dump a cup of coffee on your laptop, and you could lose your work. But the main thing is that you just get into that habit. So it's either for every sensible amount of work that you do, create a commit.
And when I was working with teams of people, I had visions. I wanted to combine a pressure sensor with a shock collar, right? And it would tie into their Git repo. And if they lifted their butt off their chair and the commit wasn't done, the shock collar goes off, But the atomic commits are great, not just from the point of view of working with others and being less likely for there to be merge conflicts. But then it also allows you to assign meaningful information to your commit name, which I think is huge. Because even if it's just you working on stuff, being able to look back through the commit history and see where you fixed this bug or where you did X, Y, or Z is super useful. And if you start touching lots more files, it's really hard to come up with a commit message that has any meaning, right?
Yeah. So that's, I guess, another part of a good commit. There's actually there's an article out there. If you like Google for like how to write the perfect commit message or something like that, I think there's like one or two like in this little series of articles that are pretty good. But yeah, I would say obviously just be descriptive in your message, and also have or sort of in the title of the commit, and then you can have like a longer message where I think Tower supports this too, right? Don't they have 2 fields?
Yes.
For commits?
Yep.
Yeah, and then in there, like I've even bulleted out like, did this. And I do that really for if I'm working on a project that's a little bit more complex with like a bigger team of people. For my own stuff, like I'm like everyone else, I tend to be a little slacking, on like specificity in the commits. But yeah, if you just kind of detail it all out, and then it really helps, like you said, Andrew, if there's a problem that you can then like Git log, one of my favorite tools. I can come in the morning and do Git log -- since equals yesterday, right? And I can see all of the commits that have happened since yesterday. Or then I can also add like author equals Ryan. I can see all of my commits. And then what it does is it allows you to see what you've been working on, or you could even see what your team has been working on to get an idea of like, where people have been or what they've been working on. And then with the descriptive commit messages, it adds all that more context to it. So you can understand, and instead of it's like, oops, or or whatever,
oops,
that we've all
oops
done.
is not a good commit message.
Trying this again. Yeah.
I've done it though.
You can also grep the commit messages too. with git log.
Right.
And so that way you can search for keywords. If you're enforcing some sort of commit message policy, then you can grep for certain keywords, whether you have to include issue numbers in them, stuff like that. So the grepping tool is pretty cool. And I'm not sure have you guys ever done like policy enforcement for commit messages or anything like that?
I haven't done that, but I think these things go hand in hand. Like the more you are doing atomic commits, where you're doing them smaller commits more frequently, the better job that you will do writing a commit message, because it's easier to write like what you did in this small specific thing. So the two kind of go hand in hand in terms of getting on board with doing smaller, more frequent commits, and you're going to end up with better commit messages. Like it's just naturally going to happen.
Also, if you're doing more frequent, smaller commits, when the day comes when you realize you've introduced a bug somewhere down the line, it's going to be a lot easier when you use the tool like Bisect to figure out exactly where that bug was introduced, instead of having like some commits where huge amounts of changes were made. You can find exactly the commit and exactly the action that caused that bug to be introduced if they're more granular.
Yeah, I'm just making a note here for bonus points for Jonathan for introducing Git Bisect.
Love Bisect. Love Git Bisect.
Free Mijingo subscription for life.
Yeah, absolutely.
Actually, I won a Mijingo. I don't know if you remember that, Ryan, but at the Peers Conference in, where was it, St. Petersburg, I was one of the winners of a lesson on Mijingo. So I got
nice.
servers for hackers, by the way.
That's a good one.
Oh, cool. Oh, yeah, by
Name.
Chris
Fideo, yeah.
Yep.
But I'm getting back to what we were talking about. So I think no matter how big or small the project is, getting on board with atomic commits is going to help you, even if it's just you. Like it's going to help you because you're going to do better commit messages. You're going to be able to find stuff better. Some other things that you can be doing in terms of Git flow, like feature branches and all that kind of stuff. When I'm working on my own, I don't tend to use those that often. But when I'm working in teams, that's when it starts to become super important to be doing the feature branch type thing.
Yeah, definitely. I'm the same way. I've tried to like do the Git flow like on projects where I'm the only committer, and it just feels like kind of a lot of work for that.
Right. So you use a tool intelligently. I mean, all I'm saying is that regardless of the scale of the project, I think atomic commits are going to end up being your friend. But some of the other features of Git flow using feature branches, which is essentially what you do is you create a branch for a specific feature, right? So you have things broken down, maybe project management style where this is the feature and you work in that until the feature is complete, and then you merge it back into the develop branch. And it's kind of a methodology for working with Git. But the big thing to take away is, use the features or scale up the features that you use as appropriate to the project you're using. Like you don't have to be making feature branches for your own plugin that no one else is ever going to work on. You can, but it's not necessary.
Yeah, one of the places I always use feature branches is like if I'm upgrading like a library or software or something like that. That's like even on my own, right? You want to isolate that out onto its own thing. But yeah, so going back to the really quick, one more thing on the atomic commits is by committing frequently, you are able to write better commit messages because you actually remember what you did.
Right.
Yep.
Where if you don't commit frequently, then you actually forget. And I would say like use whatever tool helps you to commit the easiest. So some people like Tower. There's another one on the Mac. I don't remember what it is. There's a ton on Windows as well.
There's Source Tree.
Which is by Atlassian.
There's Kraken. There's GitHub.
Yeah, Git Kraken. Shout out to Git Kraken.
Yep, and there's GitHub has its own app.
It's terrible.
Right, but if you're in just the GitHub like ecosystem, it kind of works. I use Git Lab for personal stuff.
Yep.
One thing that I've always liked is my terminal prompt actually tells me when I'm in a folder if I'm on which branch I'm on, how many,
Right.
Is it clean? Is there a clean working branch? And that just gives me this like Pavlov's dog feeling of, wait a second, it's red. I need to make it green.
Green.
Patrick's like,
Yeah.
Patrick's like, oh, I see extra merge commits. Rebase.
I should trigger my OCD in as many ways as I can. Yeah. So one thing that I wanted to call out. So you talked about how Git is a decentralized version control system. There doesn't need to be one big God server somewhere that controls everything. Everyone has their own Git repo, and they can almost exist on their own. I think that's very different to how Subversion handled things. At the same time, though, it feels like some massive percentage of all Git repos are pushing and pulling from GitHub or Bitbucket. Do you have any concerns with how decentralized it feels like Git has become?
Or you mean how centralized?
Yeah. Sorry.
Yeah. I don't have any concerns because I think that decentralization is just a feature of Git. So, and again, it's born out of that original team that developed it.
Right.
This was pre ubiquitous, like always on internet. Where and so like there's a lot more times we're going to be offline. But I see it as like the distributed version control system. The benefits there obviously are that everybody has a copy of the repository on their local machine. So there's no single point of failure with a centralized repository. And then also that you can continue your normal workflow, like even when you're not online.
Yeah, you can commit.
Yeah, you can commit. You can't push, obviously, because that's a round trip to the server, but you can commit, you can do all your work, you can branch. If you have a local branch, you can merge. So you can do all of that stuff. And then once you're connected again, you can push up. So in practical terms, like that means that you can be, on an airplane and hopefully not connected to their Wi-Fi.
I've done it
without a VPN, but you can just work, on your own without, needing, like Subversion will completely, doesn't work, right? Because you do a SVN commit and that's actually an add commit push, right? It's all those wrapped up in one,
right?
And you can't use it. But yeah, you're right. That it's essentially like, have we ever worked on a project that didn't have a central repository somewhere, or a remote repository? Because you don't want to call it central because it's not. I mean, it is technically, but you can have multiple remotes.
Yep.
Yeah, so let's take a step back, Ryan.
Some people have a remote on a server that is just for deploying to production or for deploying to here or there. So you can have like tons of different remotes.
So let's take a step back. What is a remote and what is an origin? And what are these things?
Sure. So a remote in Git is a version of the repository that is not on your machine. So it doesn't have to be on a server. It can actually be, well, no, actually, let me step back. It's a copy of the repository that you can push to because it actually can be on your machine. I think I have a video on Mijingo, I think just go to mijingo.com/lessons. I think there's one where I talk about what's called a bare Git repository. And so bare means that it's just like the innards of Git. There's no like working tree area. So it's just kind of just all the storage information. And that's actually like when you go to like GitHub or Git Lab, that's actually what you have there is like a bare Git repository. And you can set one of those up locally and you can push to it. You're just basically pointing it to a file instead of a URL, right? Because it's like, myproject.git. You're just pointing it to like path to myproject.git instead of like, SSH or, HTTPS or whatever.
And what is an origin? How does an origin fit into all of this?
Sure. So origin is just the name of a remote. And so what you do is when you set up a remote, you can have multiple remotes. You give them a name. Think of it as just like a keyword to how to address that remote. So if you do git push origin, it's just pushing to whatever you set up as that. It's typically the first remote you set up or the main remote. But you can have you can have git push staging that then pushes to another remote called staging. That might push directly to the staging server. And then you might have like a post receive hook that once it receives that push, it then, does something. Maybe it runs like some sort of little deploy script, or maybe it does like a git pull or something like that. So yeah, but you can name them anything you want. If you want to see what yours are, how yours look right now, you can just run git remote and then -v for verbose, and that'll give you the name and then the location. So, and it was like origin, or whatever. Most people probably just have, for most projects, probably just have origin.
So we can think
GitHub, sometimes they call them.
So we can think of that as an alias, and origin is just a convention.
Is a convention, right? It's just like master. Right. Master exists when you create, when you make your first commit to a project. That master branch is initialized essentially, but like you don't have to use master. You can branch that and then use something else and delete master. It's just a convention.
Yeah. What about Git as a backup strategy? I find I've talked to clients, to developers, when we're talking about backups, they say, oh, don't worry about backing up the code. We have all of our code up on GitHub or on Bitbucket or maybe even a private repo. Should it be relied on as a backup strategy?
As long as you have a remote repository that is sufficiently backed up, then yeah. And the thinking behind that is, it kind of goes a little bit further, which is when you're deploying code to a server, is, if you push this out to like a furthest extent, if you think of servers as being disposable, like think of like AWS, like you spin up an EC2 instance, and like nothing on that server should ever be like non-replaceable. So like the code should be easily deployed. The database should be like another server, in the world of AWS would be like RDS. And all your assets should be hosted like on a CDN. And so like if that server kicks the bucket, you just like, if you don't have scripts that do it, you can just spin up a new server, redeploy your code, connect it all up, and everything is still there.
Digital nomad, that's the way it should be.
Right, exactly. And that works the other way is for scaling servers then too, right? You can start deploy your code. But I'm sort of getting off the path here. But I would say Git is perfectly fine for your code backup. I don't think you need to like have like another way of backing up your code. But if you have when you have on your remote, that should be sufficiently backed up, whether that's via a service like GitHub or Git Lab or Atlassian on Bitbucket. They're pretty well backed up, but you probably want to have, depends on your thing. There's other tools that back up Git for you. I think it's called I can't remember, but there's services out there that'll pull it down and do it for you. But I don't really see a huge need for other than like occasional snapshots. I don't think GitHub is going to lose like all of your code. Although, I guess it's possible.
Gosh.
Yeah.
I would say that just having a Git repo is not necessarily a backup strategy unless that Git repo is either replicated somewhere or backed up somehow. You know what I mean? So, for instance, I have my own private Git server, which is shockingly easy to set up, by the way. So very, very simple to set up your own Git server. And that is deploying from there to the various websites, but I still back up what is on that Git server, if that makes sense, right? Because yes, it's true that if that server where my Git repo is annihilated, there is going to be a copy of the repo somewhere else, but I would like there to be an actual official backup of that somewhere.
And not only that, you're also going to have a copy of the repository on your computer too.
You are, but you just pray that it's up to date and.
Sure. I'm just talking about like just in terms of like there's some built-in redundancy.
Absolutely.
There, but to your point, Andrew, I think it's the same as you would think about anything. Any data, just make sure you have a backup plan.
Right.
But yeah.
Terrific. Anything else, Andrew? Earl, Jonathan, anything else you want to ask?
Yeah, Earl, what questions do you have? Like, you've been using Git for a while, and I think like all of us, like there's just a huge stack of technology, and we can't learn everything, right? So to some extent, we just use the pieces that we need to use, and maybe don't understand how everything works under the hood. Is there anything that you want to know about Git while we got Ryan here?
Well, it's not. I guess it's not super specific. Other than I wanted to see if anybody had any. I have never used Git in the command line. Is there anything that you can think of off the top of your head that I'm totally missing? And I know that's probably going to be software dependent. Like, Git Kraken has some features that maybe, Atlassian's doesn't, or whatever, vice versa. But is there anything off the top of your head that you use in command line where you'd be like, you need this, you're missing out?
I don't think there's anything that you're probably missing. I would say that in my the times that I've taught Git to people like in person where I can get immediate feedback, the ones that were the most confused were the ones that had relied on like GUI apps for Git because they had a certain like understanding of how Git worked, and that was formed by the UI of that app. And so I think that I always teach it on the command line. Like I'll reference another app if they ask me to customize the course to do that, where I'm like, and this is how you do it in, such and such, like, .NET tool or like in the enterprise, for what's the big .NET, or no, what's the big, anyway, whatever that IDE is.
Eclipse.
So I think that's the biggest thing, but you're probably not missing anything per se. You probably can't do anything better from the command line. I mean, it's certainly like less type. The command line's a ton of typing. Like I get pretty, like if you're doing a lot of commits, it get pretty fatiguing from the command line for sure. One of the things I really like about the GUI apps though is a lot of the graphical displays of like the status of the repository.
So nice.
I mean, you can get it. Yeah, you can get it. Like if you do git log, I think it's -- graph, it'll show you like the branching and stuff. And it's like, like colored and stuff like that. But like, like things like Tower, sometimes it's just like for like just getting an overview of where things are and what's happened. It's pretty superior, I think.
I'm pretty comfortable using Git from the command line, but I use Tower because I find that it makes a lot of things just easier for me, especially the Git flow and then also visualizing it. And I mean, there's no inherent goodness about using the terminal. Use that for things that you can do quicker in the terminal, and use a GUI for things that work better from a GUI. Kind of to address Earl's question, my only thing that I think you're missing out on is you might be missing out on a kind of fundamental understanding of how Git works. Yeah. And then the question is, does it matter? And for, and for a lot of people that are using Git, maybe it doesn't matter. Or maybe it's one of those cases where it doesn't matter until it matters, right? Until something, goes horribly wrong. But I mean, in my personal opinion, I don't think you're really missing out on a ton by not using Git from the command line. I think some of the clients that are out there are pretty fantastic, but I do think that there's a lot of merit to what Ryan was saying about exploring around and seeing how it works under the hood, just so you have this kind of mental comfort zone of understanding what is going on.
So go home and command line into the .git file and just start moving things around.
No.
No, that's what I'm doing. That's what you said.
What you're missing, Earl, is actually doing the world's longest commit. You can't do that from the GUI app.
Oh, that's true. Yeah, and I do. Yeah. Well, I mean, I agree.
Speaking to Ryan's point about there's a lot of typing, if you use the command line, definitely true. So this is super nerdy, but if anybody uses or they've installed Oh My Z Shell or Oh My ZSA, so they have a really good plugin that you can use for Git, which greatly shortens the amount of typing with a lot of aliases that they've pre-created for you. So I like using that. The only downside is I've probably forgotten the real way of doing it because I just rely on all of these aliases. So,
that's a good point about aliases, though, because I use them in Bash. So I just created some Bash aliases like Git, even things like GS for Git status. Yep. Or sometimes I think I used to use Git st, just anything to save, especially those commands you need to type really quickly just to see like what happened, right? Then or where am I?
I use
Yeah,
glog
exactly.
and then aliases to exactly the way that I like to see my log
Right.
displayed.
Yeah, and you can do that in like your shell environment, your aliases, and Git itself also has, you can do actual Git aliases like right inside of Git too, that are not shell specific. So you can, you just Google for that.
So Patrick, if I could, I actually thought of one thing that maybe we should just touch upon really quick. What is a pull request, Ryan? What is it?
A pull request is actually not a Git concept. So this is like GitHub, and essentially it is a request to merge. Like it's saying, I have a branch with some changes. Can you please look at this and then merge it in? It was built around open source projects where there's a lot of contributors, and there's typically a smaller amount of actually maintainers that have like, I guess it's beyond commit rights. I'm not sure actually how they call it, but people that can actually merge into like master or into develop that have access to those branches.
Right.
And you create the pull request or PR, and you say like what you're doing, what your changes are, and it has it's basically just a merge that hasn't been merged. Essentially, it's just like a staged merge, basically. But it's very specific to GitHub. Git Lab does it. All the big tools do it now. On Git Lab, they call it a merge request.
Right.
But they call it, yeah.
Even outside of open source projects, a number of companies that I've worked with, that's how they work internally, right? So someone will be working on a big project and they cannot just merge it. They issue a pull request, and then that's where some code review is done.
Right. Yeah. I work on a project right now where I don't have access to master or develop. Well, no, actually I do, but it's sort of, there's guidelines to where like, only a couple of people do, because this is an e-commerce thing. So you have to kind of be careful about what you're merging in.
Right.
And so, I just do I'll do a feature branch, and then I'll just do a pull request right on GitHub, and just, detail my changes. Also detail, like if there's any database configuration that needs to be done, like after the merge, like I'll detail like what that is. And so it's a way of organizing. It works great with Git flow, right? It sort of falls right into that. But it's definitely not a Git thing. You don't need to know about pull requests to learn Git, but in our day today with like GitHub tools and GitLab, it's a thing.
Yeah, and it's a workflow thing that allows for a little bit of oversight, right? It allows someone to do their job, finish it to where they think it's finished, and then it allows someone to then do code review or just make sure best practices are followed. And it's something that for larger projects can be super, super useful when you have those layers of different developers that can be working on the same project.
Yeah, and then sometimes the pull request will go into like a QA branch or a or a UAT branch or something, right? And they will get pulled into there, and so you'll have different people, and it's very handy.
Yeah,
not so Wild Westy as like just merging in and pushing to origin.
We just upload stuff directly to the server, man. We're cowboy here.
Edit on the server.
One other question I had, maybe it's the last one, but Git modules. So Git has the idea of doing what are called Git modules, where you can almost have a sub Git repo pulled into your repo. I always had a tough time with them, just never having them work quite right. And I feel like I've really gone away from them now that we have Node and Composer on PHP and other ways of pulling in other projects and other libraries. Do you still find a use for Git modules?
I don't personally use them a lot. I mean, where they could come in handy is if you are working on a larger app, and it was broken up into pieces. Then it could be, but I don't personally use them a ton. They can be a little finicky to work with.
Mm-hmm.
Right. Okay, it's not just me. Okay, it's not just me. Okay, good.
I had a full head of hair before I started working with submodules. No, there are cases where I've used them that they actually have been very useful. So there was an app core, right? And that was in its own repo, and we wanted that to be separate. But that was used inside of a larger Git project that was kind of scaffolded out on top of that. And it is kind of nice from that regard, because one of the things that submodules can do for you is you can update everything at the same time if you want to.
Right.
I too have encountered that this glorious world of being able to do all that kind of stuff just doesn't end up working out all that well in practice. So I have, outside of a few very specialized projects, I have kind of given up on using them.
Cool. All right, it's not just me. Thank
No.
goodness.
No, yeah, and so but just to kind of like quickly define, like there's two things. There's submodules, which is basically when you're pulling in an external repository, that's like a dependency of the project. Like if we're talking about like craft CMS, like maybe you pull in. I mean, you don't do this because we're pulling plugins in other ways now, but like if you have like a library or a plugin or something that your project depends on to run, like you could submodule that.
And that's what I was doing. All of my plugins were submodules, right? And the glorious thing about that, or the glorious thing in theory, is that I could just update all of the submodules at the same time. And it did work, but there were definitely issues with getting everything to play nice.
Yeah.
Go ahead, Ryan.
Yeah, and then the other one is subtrees, which is like another way of pulling in outside code into your project, and you use you use them for different reasons. The submodule is more like an active, fully fledged outside repository, and a tree is more like you're pulling it in, kind of squashing it and kind of dropping it in.
Yeah, so, and to Patrick's point, I think the reason, the tooling that we work with most days, or most of the time now, has better ways of doing this. Like Craft has moved to Composer, Node, and a number of other things that you can be doing instead of doing that.
Right. Now there are still, one of the teams that I taught, like the project is massive, and there might be like 30 or 40 teams working on the project, and so they actually do rely on submoduling,
right? Because
they do actually have to integrate. Like they don't have like a monolith project. They have a bunch of like microservices or little micro apps that then all work together. And so they do use submodules though, and they sort of deal with the pain that comes with them.
Terrific. So there are places where Git could improve. Good. All right. Well, I think that's all the time we have. Ryan, if people want to find out more, if people want to learn Git, where should they go?
Sure. If you want to learn Git on your own, just with some video-based training, you can go to Mijingo.com. That's Mijingo. Let me say it again.
Mijingo.
Can you edit that out?
No.
No editing here. Mijingo.com/Git, and that'll bring you everything. If you want to learn about classroom training, you just go to getclassroomtraining.com, and that'll bring you to some just general information on how to get in touch about classroom training.
Using promo code?
Oh, I don't have a promo code, but I can
just make one up, and then you can create it.
Yeah, let's see. Promo code
devMode.
devMode.
Boom.
Nice.
I like it.
Let me go input this into my system before I forget.
You've got a few days. Don't worry.
No, I'll forget if I don't do it immediately. I'm like a goldfish.
Man, knowing that, I don't know if I want you messing around on the command line with Git.
Awesome. Thanks for joining us today, Ryan.
That
wraps it up for another episode of the devMode FM podcast. To have every episode delivered to your favorite podcast player, subscribe to our RSS or subscribe via iTunes or Google Play. And if you like what you're doing, please leave us a review. You can also follow us on Twitter @devModeFM. And we love to hear your thoughts on the episode. Leave us a comment right on devMode.fm. For the devMode.fm podcast, I'm Patrick Harrington.
I'm Andrew Welch.
I'm Earl Johnston.
I'm Jonathan Melville.
And thank you very much today, Ryan.
Thanks a lot, guys.
Thanks, man.
Bye-bye.